Hi, my name is Scott Lindsay. Today we're going to go over getting started with probing. Probing is an add-on in Mastercam. Up here I've got a program here, a simple program that I've got started. We're going to face it, and we're going to machine a feature and add some probing toolpaths to it. If you come up here to probing, it's going to ask us what probe we want. We can have multiple probes loaded in our machine. The default one that comes up, you can use that one. It's going to have a -1 here in the toolpath number, in the tool number. You can just change that to something that would be on your machine. I picked 25 on this one. I'm going to go ahead and say OK with that one. Okay, the first thing I want to do on my part is I want to set up touching off the G54Z. So I'm going to say measure point. And I'll come out here, I'm going to pick a point on my face, and I'm going to say measure point. Now on here, I'm going to keep everything kind of named that makes sense. So I'm going to say measure Z, so that I keep track of what these points are. Because if I get down here at the end and I have 10 points, I'm not going to remember which one does what. So keep everything named so it makes sense. After we've measured that, we want to do something with it. So I'm going to come up here to NC Update. I'm going to click on this, and I'm going to tell it that I want to update my work offset. Because we have these are our options. I'm going to update my work offset. I'm going to pull the work offset that's tied to my top plane. So whatever value I have down here in my planes is what's going to get populated here. This set and update feature, update is going to add whatever value Z value that I pull out of this point to whatever offset I already have in my machine. So we want to actually set it to the value that we measure. We don't want to add to it, because that's not what we want to do on this guy. So we're going to set it from the feature. I'm going to tell it to look at the feature, and I'm going to say measure Z. Now it's looking at that point that we've measured, and I'm going to take, and I want to offset it down 20 thou from that feature, so that when I machine the face, it cleans up that 20 thou on the face of the part. And we are going to use the Z. And yes, we are. I'm going to green check out of that. And it's going to create that probing routine and set our work offset Z. Now we want to come up, I'm going to create another probing cycle, and I'm going to do a web measure, a web pocket measure. And on this guy, we're going to give him a good name here, and we're going to call him measure X and Y. Okay, when you're doing your naming, make sure, because of the logic routines and stuff like that going on, we can't start with a number. We have to start with a letter. So you can't start with numbers, and you can't have spaces. So I use the underscores to do my spaces. But anything that keeps us knowing what this cycle and keep them unique. So this point, I'm going to come out here. We're going to click here, and this is going to be in the direction that we want to measure. Okay, parallel to the side that we want to measure. So we're wanting to measure this side, so we pick the center of these two sides, and now I'm going to come in here and specify the width of what I want to measure. I'm going to measure the outside. Now down here on the start clearance, this is from this corner or from this corner in. So if we don't put any start clearance in here, then it's going to come and measure right on this corner. And we want to offset it in so it measures in here on something that's substantial. So I'm going to bump him in 25 thou on each side. We're going to have 3 points. So we're going to measure 3 times across here. This shortest distance is going to kind of this icon. You can see that once it gets done measuring, it's going to move at a diagonal angle to the next start point of where it needs to clearance the part. But if we switch this to linear, then it's going to pull out and move over and come straight in. Okay, so on this guy I want linear, It wouldn't really matter, but it just looks cleaner and safer moves. We're gonna move to our safety clearance plane, and yeah, we should be all good. So we've measured the web. We can come out here and see what it done. We come in and beat this side 3 times, then this side, and then we measured the ends. If we didn't want it to measure the ends, we can come in here and say measure ends and turn this to a no, and that would eliminate these moves and just measure this side. Okay, but for what we're doing, we want all sides of this part. Okay, after we've done measured it, we want to come in here and we want to do another NC update. We're going to update the work offset. We're going to pull the work offset from top plane. We're going to set it, and we're going to pull it from the feature of XY measure. We don't want to do any offset because we want it right in the middle of this stock that we have on here. And this is where we can choose what about this pocket measure that we want to pull. Do we want to pull both the X and the Y? And we do on this example. So we're going to regen this guy, and now we have an NC update that's going to set our X and Y. And we got our machine set. We're going to come in here and we're going to face the part, and then we're going to rough our circle. We're going to rough out our circle. Now, I've broken this up. I could have machined this all in one op, but after this circle has been measured, I want to be able to rework the hole if I need to. And so I need a finish toolpath to be separate from my roughing toolpath so that I can get in between here with my probing logic. Okay, so we're going to start right here. We need to create some labels of how we want this to move around in our program. So up here in our probing, we're going to come in here and we need to create these labels out here in our main program. So I'm going to create label 1. I'm going to give him a name, and I'm going to call him rework hole. Okay. So now I've got a label called rework hole. Okay. Now I'm going to skip down because that's I've roughed it. Now I've got a label in here called rework hole, and now I'm finishing it. Here is where we're going to add another label, and this one I'm going to call hole good. Okay, and then we're going to come down here to the end of our program, and I'm going to create another label, and I'm going to call him scrap. Okay, so now I've got 3 labels in here, which is, you're probably going to at least have 2 if not 3, because you're going to have if it's reworkable, if it's good, and if it's bad. You've got three options of what's going on here. So if we come up after here on our circle mill where we finished it, we've got our good label and all that stuff. Now we want to create the measuring routine that's going to check our hole. So I'm going to come in here to my probing, and we're going to do a circle measure, and I'm going to grab that circle of that part, and he's going to input his information in here for us. We're going to do the inside. We're going to go to this depth. This is from the equator of the ruby, from the surface down. So if you are close to the bottom of your hole, you want to make sure that you don't hit the bottom of your hole. So keep that in mind there. If we needed to start the angle at a different thing on this part, it's not like it's got a slot through it or something where we were worried about that. We're all good. I'm going to say 4 points on this guy, and we should be good. So we've measured the hole. Let's give him a good name. I'll just call this one hole because we're trying to keep this simple, but you might have to get more descriptive on what stuff means. And maybe you've got a inspection report where the features are numbered, and you could say hole and then give it a feature number 10 or something like that. You could keep it straight that way. Okay, after we've measured the hole, we want to add some logic in here to check and do certain things. So after the hole is measured, I'm going to put in this if statement. So if, and it's going to ask a question. So we're looking at something about hole one, hole, and I'm looking at the diameter of hole. My controlling statement, so this is if it's less than, and I'm going to come in here. Now, don't come in here and just double click this, because now I'm checking hole, the value of hole to the value of hole, which is not a good thing to do. We want to come in here and right click, and we want to say set nominal value, which will tell me whatever this is. It's the same as going out here and analyzing this and outputting it myself. And then I can do math in this equation, so I can go minus 0.05. So this is going to be checking the bottom end of the hole, so our MMC. Okay, if it's at MMC or less than that, we can fix the part and make it good. Okay, so we're checking this to this. So that's our question. Now, if this question returns a positive, or a true statement, then we're going to do what? What are we going to do? First thing we want to do is we want to update. We want to update our tool diameter, our wear. So we're going to update the tool diameter of tool 1, right? Because see, we're coming out here, oh, tool 2 is what we're using. So tool 2 from feature is going to be hole, and we're going to update the wear offset on the control. This feedback is how much of that deviation we're going to feed back to control. If you want to shrink this down and creep up on it, you can, but I'm going to feed back 100% of that feature to the machine. Okay, after we've updated the machine to compensate the tool, we want to come back and we want to rework the hole. So now we're going to do a go-to label. Okay, so it plugged in the go-to label. We don't need this label because it's kind of, and we're going to drop in here and we're going to say we're going to go to rework hole. So if it's small, we're going to update the tool and we're going to go remachine that feature. Okay, so now we have our then statement, which is all we need. Okay, but we want to check some other stuff. So I'm going to come in here and I'm going to say else, and then I like to come in here and just add my else if right in the middle. Okay, so I've got my else if. So this is my second then statement. So my condition is hole diameter is less than, and I'm going to come in here to hole diameter nominal value, and this is the other side of my tolerance, so I'm going to go plus 5. Okay, if this statement is true, I want to still update the control because I want to make it perfect, right? So I mean, we could hit tolerance, but we could just barely be in it, and we don't want to always be running right at the top of our bottom of our tolerance. So I'm going to update the NC. Stick this guy right there. I'm going to update the tool diameter, tool 2. Feature, I'm going to pull it from that hole again, and I'm going to update the wear offset. Now I'm going to go back to my go-to labels, and we are going to go to label hole good, because the part is good, right? So we'll lose this guy. So now if neither one of these statements is true, then the part has to be bad. The hole's too big and we can't fix it. So the else is just a go-to label. Oh, well, we don't want a label. We want to go-to label. So we want to go to, we're going to stick him right there. And delete, and delete. And this guy is going to go to scrap. Okay. So that's our probing cycle. So now we're going to check the hole. We're going to hop up here to this rework, rerun this finishing toolpath, check it again, make any offsets. If it's good, we're going to come to here. If it's bad, we're going to hop down here at the end of our program and hit our M30. We could come in here and add, we could come in here to any one of these. Like say we went to in our probing cycle here. We could also come in here at the end of our scrap, and before we scrapped it, we could come in here to our G code, and let's stick that guy right there. Come on. Okay, and we could come in here and we could put in like a note that says MOO part is bad. So we can add G code in here that would then tell us why the machine stopped. Because if we have a bunch of conditions and we're all kicking down to the end of the program, we might not know where we are in the program when we came back and this machine is sitting here, scrap our part. We don't know what feature was bad at what point. So we can come in here and put some information in here that's helpful for us. So when we hit what we're doing, we know what's going on. If you need a custom RANMF file or have any questions, please contact us. I'll be happy to help you out. Have a good day.